Hi students, in this video I am going to explain you the new chapter, Trigonometry, Introduction to Trigonometry, very important even for your future studies also. This is very careful. I will give you the basics of the trigonometry and then we start with the exercise 8.1 and 8.2. Okay, see, trigonometry basically depends on the right angle triangle. The right angle triangle. Say, in a right angle triangle, what concept we use generally? We take the concept of Pythagoras Theorem. That means, if you know any two sides of a triangle, if it is A and if it is B and if it is C, you can find out the other side using Pythagoras Theorem. What does Pythagoras Theorem says? AC square equal to AB square plus BC square. That means C square is equal to A square plus B square. BC is okay. Like that. You can take this as A and this as okay. B. Anything you can take. A square. So if one of the side is unknown, then you can find out the other side, the unknown side, using this formula. This is Pythagoras Theorem. So after finding this, what happens? What happens after finding this? Suppose I will give you an example. Suppose if I know the value of this 2 and this is some 3. How to find out this? Now I take like this. This is 90. So always hypotenuse square equal to, we don't know this. We take x. X square plus 2 square. So 9 minus 4 is equal to x square. 5 is equal to x square. X equal to root 5. Like that we will find out the unknown value using Pythagoras Theorem. This is the first basic concept. After finding the Pythagoras Theorem, after finding the unknown value, how this right angle triangle is useful in finding the, in doing trigonometry actually. I tell you. See, in trigonometry, in right angle triangle, you will have 3 angles, 3 vertices, and one is fixed angle, 90 degrees. Since the sum of the angles is 180, the other 2 angles should be acute. These 2 should be acute, and sum of these 2 will be equal to 90, because one is 90 already. The sum of the other 2 must be 90, and those 2 are acute angles. Okay. Now, suppose if one of the acute angle you take it as a theta, we name the sides. No doubt we know that hypotenuse is the largest side of a right angle triangle. Okay. So if this is the largest side, what about the other 2 sides? We name the other 2 sides depending on the reference theta we take. Theta means the angle that we consider. So if theta is here, the side which is opposite to theta, we take it as opposite side. The side which is adjacent to theta is adjacent side. Suppose if I take right angle triangle like this, ABC, and this is hypotenuse, no doubt, the largest side is always hypotenuse. If I take theta here, so among these 2 you can take theta anywhere. If you take theta here, this can be considered theta, opposite side. Opposite to whom? Opposite to theta, opposite side, and this is adjacent side. We take this as adjacent side. Okay, we have 3 sides. Suppose I tell you with an example. We have 6 trigonometric ratios to write. Sin A, sin theta we write. Sin theta, cos theta, tan theta, cosecant theta, secant theta, cot theta. These are the ratios. Sir, why we call secant, cosecant? Why don't we call with some other? We have to call with these names because these are universal. Everywhere in world they call like this only. They don't call with some other names like Ravi theta, Ram theta, like that they don't call. They call with sin theta, cos theta only. So how these ratios are divided with these sides? I'll tell you. See, why this order is also very important. That depends on the theta. Okay. Before going to this, I'll tell you. We have 3 sides: O, A, H. O, A, H. Opposite side, adjacent side, hypotenuse. Suppose if you have 3 values with you, how many ratios that you can make with those 3 values? How many ratios maximum possible ratios that you can make, I'll tell you. I can make O by H, I can make A by H, I can make O by A, I can make H by O, I can make H by A, I can make A by O. Any other thing is missing, you please check. Nothing will be missing. These are the 6 only possibilities that we can make. These are the 6 possible ratios that we can make with these 3 values. Any 3 values you can take, 3 different values which cannot be simplified, so that you can make only 6 ratios. A by H over, A by H over, H by A is over, O by, everything is there. So how many ratios we could make? We could make only 6 ratios. So for those 6 ratios, these are named. And these are named particularly with the specific terms, and we have to follow those specific ratios with these particular names. Okay, sin theta is taken as opposite side by hypotenuse. Cos theta is adjacent by hypotenuse. Tan theta is opposite side by adjacent side. And these 3 are nothing but just the reciprocals of these 3. Just the reciprocals. So cosecant theta you can take it as hypotenuse by opposite. Secant theta you can take it as hypotenuse by adjacent. Cot theta you can take it as adjacent by opposite. From these 6, you can make some other link also. How? Sin theta can be taken as 1 by cosecant theta, and cosecant theta can be taken as 1 by sin theta. You can write like this also. Sin theta is nothing but 1 by cosecant, cosecant is nothing but 1 by sin. In the same way, cos theta can be written as 1 by secant theta, and secant theta can be taken as 1 by cos theta. So tan theta can be taken as 1 by cot theta, and cot theta can be taken as 1 by tan theta. Like that you can write. And one more thing, you can also take it as cos theta is sin theta, tan theta can be written as tan theta is equal to sin theta by cos theta. See, when you divide sin by cos, what happens? Hypotenuse gets cancelled. You will get a tan theta opposite by adjacent. And cot theta can be taken as cos theta by sin theta. These are the basic things required for the first exercise. Okay. Please pause the video and check it carefully, guys. See, the opposite and adjacent angles should be depending on the theta that you take. Sometimes they don't take theta. I'll tell you. I'll rub this. Sometimes they don't take theta, and they call with the names with the vertices only. Suppose if this is like this, ABC. They don't take theta itself, and they want to write what is sine A. What is sine? Basic principle of sine theta. It is opposite side by hypotenuse from this triangle. Okay. Opposite side means opposite to whom? Opposite to the angle they take. So what is the angle they have taken here? A. What is opposite side to A? BC by AC. Suppose if they ask us cos C means adjacent by hypotenuse. Adjacent to whom? Adjacent to the angle that they take. What angle they took? C, this angle. So what is adjacent to C? BC. Adjacent to C is BC. If they don't take theta, we have to do like this. Sir, can we take sine B? No. This is the fixed thing. You are supposed to take only these for acute angles, not for the right angle. Sine theta, cos theta. Sir, what happens if we take it for right angle? It will come in the next exercise. So, you are supposed to take only either this acute angle or this acute angle for all these 6 trigonometric ratios for now. Okay? Now, 90 degrees we don't take. And these opposite adjacent sides depends on the angle that we consider. Okay? Let us start the exercise. I'll explain the problem. Exercise 8.1. Exercise 8.1. See, in the first question, they have given in a right angle triangle at B. In a right angle triangle at B, ABC, AB is equal to 24 and BC is equal to 7. You are asked to find out sin A, cos A, sin C, cos C. Okay, let us see. See, first of all, in this right angle triangle, what we have to do? We have to find out the hypotenuse. Hypotenuse is missing. So, how to find out hypotenuse? Using Pythagoras Theorem. AC square is AB square plus BC square. So, AC square is 24 square plus 7 square. So, AC square is equal to 576 plus 49. AC square is 625. So, AC is equal to root of 625. That is equal to 25. So, this is the thing. Third side we got. Hypotenuse is 25, no doubt. Now, what did they ask us to find out? Sin A. Okay. What is sin A? A is here. What is sin formula actually? Opposite by hypotenuse. Opposite to whom? Opposite to the angle that we take. Opposite to the angle A. What is opposite to angle A? 7. So 7 by hypotenuse. 25. What is cos A? Adjacent by hypotenuse. Adjacent to whom? Adjacent to the angle that we take. Angle is A here. So what is adjacent to angle A? 24. You can also say that, sir, hypotenuse is also adjacent to angle A. Why don't we take? We don't take hypotenuse. So except the hypotenuse and the 90 degrees, we consider the rest of the things in the right angle triangle. We should not consider hypotenuse and 90 degrees. You may have doubt that, sir, when you are taking adjacent side, you are taking only AB. Why are you not taking hypotenuse? So hypotenuse and right angle, these are fixed and we don't touch them. Okay. What is sin C? Again, sin means opposite by hypotenuse. Opposite to whom? Angle C. Opposite to angle C is 24 by 25. And cos C, adjacent by hypotenuse. Adjacent to whom? Adjacent to C. So it is 7 by 25. Like this we find out sin A, cos A, sin C, cos C. Right? See, in the next question, they have given a figure. Right angle triangle like this. Q here at right angle, P, R, and 12 and 13. So let us find out the unknown side for it first. What is the unknown side here? So let us apply Pythagoras Theorem. We know that PQ square plus QR square is equal to PR square. We don't know QR. We know PQ. 12 square plus QR square is equal to 13 square. So QR square is equal to 169 minus 144. QR square is 25. So QR is equal to 5. This is 5. So we found out the unknown side. After finding unknown side, what did they ask us to find? Okay, tan P minus cot R. Tan P minus cot R. Okay. Tan P. Tan P means opposite by adjacent side. This is adjacent side by opposite. But here, opposite means opposite to whom? Opposite to P. Opposite to P is 5. Adjacent to P is 12. Okay. Adjacent to, because this is tan P. Tan P. Now cot R. Cot R. Okay. R. R is here. Adjacent to R is 5. And opposite to R. Opposite to R is 12. So 5 by 12 minus 5 by 12, it is 0. Okay. See the next question. They have given if sin A is equal to 3 by 4, calculate cos A and tan A. Okay. Let us find out sin A is equal to 3 by 4 they have given. That means opposite by hypotenuse is equal to 3 by 4. It is given. So let us take a triangle with A here, B here, C. Opposite side is 3. Opposite to whom? Opposite to A, it is 3 and hypotenuse is 4. That means we don't know this. We don't know this. So let us find out this using AB square plus BC square equal to AC square. AB square we don't know. BC square 3 square. AC square 4 square. So AB square is equal to 16 minus 9. AB square is equal to 7. AB is equal to root 7. We got root 7. After getting root 7, what did they ask us to find out? They asked us to find cos A and tan A. Okay. Cos A is equal to adjacent by hypotenuse. So adjacent means adjacent to whom? Adjacent to A. A. Who is adjacent to A? Root 7 by 4. Hypotenuse is 4. Next one is tan A. Tan A is opposite by adjacent. Opposite to whom? Opposite to angle A. Opposite to angle A is 3 and adjacent is root 7. Adjacent to. Don't consider adjacent as hypotenuse, never. This is the problem. Next one, fourth problem. They are given 15 cot A. 15 cot A is equal to 8. Find sin A and secant A. Same problem. We do the same way. See, 15 cot A is equal to 8. That means cot A is equal to 8 by 15. Take a right angle triangle first of all. This is adjacent by opposite. So let us take A. It is A, no? They have given A. So let us take A here, B here, C here. Adjacent to A, 8. Opposite to A, 15. So let us find out this one. So we know AC square is using Pythagoras. AB square plus BC square. 64 plus 15 square, 225. That is 289. So AC is equal to 17. This is 17. Now after getting this, what did they ask us? To find out sin A and secant A. Sin A. Sin A is opposite by hypotenuse. Opposite to whom? Angle A. Angle A. So opposite angle is 15 by 17. Secant A. Secant A is hypotenuse by adjacent. Hypotenuse is 17. Adjacent to A. Who is adjacent to A? It is 8. 17 by 8. Right? See the fifth problem. Secant theta is equal to 13 by 12. You are asked to find out all the rest of the trigonometric ratios. Okay? We take secant theta. Secant theta means adjacent by hypotenuse is 13 by 12. So let us take a triangle. Okay, let us take theta here. Theta. Okay, adjacent by hypotenuse. Adjacent is this. Sorry. Secant is hypotenuse by adjacent. Hypotenuse is this 13. Adjacent to theta. I took theta here. 12. We'll find out this. A, B, C. So AB square plus using Pythagoras theorem is AC square. So AB square plus BC square is 144. AC square is 169. AB square is 25. So AB is equal to 5. So we got this as 5. The other trigonometric ratios. Sin theta. Sin theta is opposite by hypotenuse. Opposite to whom? Theta. So 5 by 13. Cos theta. Adjacent side by hypotenuse. Adjacent to whom? Adjacent to theta. 12 by 13. 12 by 13. Tan theta. Opposite by adjacent. Opposite by adjacent. 5 by 12. Cosecant theta. Hypotenuse by opposite. 13 by 5. Secant theta. Hypotenuse by adjacent. 13 by 12. Secant it is over already. Cot theta. Adjacent by opposite. Adjacent to whom? Theta. Theta is here 12 by opposite is 5. 12 by 5. Right? See in this question you can do it in simple way. Angle A and angle B are acute angles of a triangle. Right angle triangle. Angle A and angle B. So we take angle B here, C here we take. And you are given cos A is equal to cos B. And we have to prove that angle A is equal to angle B. These two are acute angles and we are told that cos A is equal to cos B. Okay, we consider right angle triangle. Right? Okay. What is cos A? Adjacent by hypotenuse. This is also adjacent by hypotenuse. But only thing different is here adjacent means adjacent to whom? Adjacent to angle A. Here adjacent means adjacent to angle B. Okay. What is adjacent to angle A? It is AC. By hypotenuse is AB. Here adjacent means adjacent to B is BC. By hypotenuse is again AB. You can cancel these two. What did we get? AC equal to BC. When two sides are equal, it becomes isosceles triangle. ABC is an isosceles right triangle. Right triangle. We write ACB. Right triangle. Right angle at right angle at C. When these isosceles triangles, when two sides are equal, the corresponding angles are also equal. Therefore, angle A is equal to angle B. I'm sorry, angle B. Right? Next one, they have given 7. Cot theta is equal to 7 by 8, and you are asked to evaluate this one. 1 plus sine theta into 1 minus sine theta by 1 plus cos theta into 1 minus cos theta, and also cot square theta. Let us see. How to find out this? You can do it simple way. Take a right angle triangle, cot theta ABC. I take theta here, adjacent side by adjacent by opposite whom to theta. So adjacent opposite 8. Let us find out this square root of 49. Okay, otherwise we take Pythagoras. AC square is equal to AB square plus BC square. That is equal to 8 square plus 7 square. 64 plus 49. 113. So AC is equal to square root 113. From this, what we know? We take sine theta is equal to opposite by hypotenuse. What is opposite? 8. This is root 113 by root 113. Cos theta is adjacent by hypotenuse. Adjacent to whom? Theta. 7 by root 113. Okay, now after getting this, let us find out this value. Now when you take this, it looks like a plus b, a minus b, a plus b into a minus b. A plus b into a minus b become a square minus b square. Sine square theta. Remember carefully when you write this in trigonometry ratio, some people get confused. Sine theta, when you take whole square, it becomes sine square theta. Don't think that it becomes sine square theta square. No need to square the angle. It is completely the function. Sine is an operator here. So you have to write it as sine square theta by denominator also 1 minus cos square theta. Let us substitute this. 1 minus sine square theta. Sine theta is this. So 8 by root 13 whole square. 8 by root 113 whole square by 1 minus 7 by root 113 whole square. It becomes 1 minus 64 by 113. 1 minus 49 by 113. So it becomes, when you take LCM, 113 minus 64, 113 minus 49. So it becomes, that is equal to 113 minus 64 is 49 by 64. That's it. This is the value. Now they also ask us to find out cot square theta. It is nothing but cot theta whole square. Cot theta whole square, 7 by 8 whole square. It becomes 49 by 64. Okay? Okay, see the 8th problem. If 3 cot A is equal to 4, find, you have to check whether 1 minus tan square A by 1 plus tan square A will be equal to cos square A minus sin square A. We do both LHS and RHS and we find out, okay? And we see whether it is correct or not. Let us see. Okay, 3 cot A 4 means cot A is equal to 4 by 3. Okay, take a right triangle, A, B, C. We take A here. Cot means adjacent by opposite. So adjacent to who? A. 4, 3. And this becomes, using Pythagoras, AC square is AB square plus BC square. 9 plus 16 plus 9, 25. So AC is equal to 5. AC is 5. Okay, let us find out tan. The other trigonometric ratios also. We need sin A. Sin A is opposite by hypotenuse. Opposite to whom? Opposite to A. So it is 3 by 5. And cos A. Cos A is adjacent by hypotenuse. Adjacent to whom? Adjacent to A. Adjacent to A, it is 4. 4 by 5. Okay, now tan A also we need. Tan A means opposite by adjacent. Opposite and adjacent to whom? To A. So 3 by 4. 3 by 4. So let us substitute. First we do LHS. LHS. 1 minus tan square A by 1 plus tan square A. That is equal to 1 minus tan square A, the square of this. 9 by 16 by 1 plus 9 by 16. So LCM in the numerator is 16. 16 minus 9. LCM in the denominator is also 16. 16 plus 9. 7 by 25. Now RHS. RHS. Cos square A minus sin square A. So cos square A is just square of cos. 16 by 25 minus sin square A. 9 by 25. 7 by 25. So therefore what you can conclude? You can conclude that LHS is equal to RHS. Okay. See the ninth question. In triangle ABC, right angle at B. Right angle at B they told us. So we take ABC. Anyway, you can take A here, C here also. Tan A. Tan A is given as 1 by root 3. And you are asked to find out sin A cos C plus cos A sin C. Also, sin A cos C minus cos A sin C. That means we need sin A cos A, sin C cos C. Let us find out. Okay. Tan means opposite by adjacent. Opposite to whom? A. So 1 by root 3. Okay. Let us find out AC using Pythagoras. AC square is AB square plus BC square. So 1 square plus root 3 whole square is 3. It is 4. So AC is 2. Now after getting this, let us find out all the values. Sin A cos A. Okay. Let us find out here. Sin A is opposite by hypotenuse. I am writing here opposite by hypotenuse. That is equal to 1 by 2. Cos A adjacent by hypotenuse. Adjacent to whom? To A. To A. That is root 3 by 2. Okay. In the same way, I write here later. Sin C. Sin C opposite by hypotenuse. Opposite to C now here. Opposite to C. So root 3 by 2. And cos C adjacent by hypotenuse. Adjacent to whom? Adjacent to C. Adjacent to C. 1 by 2. So let us substitute all these values here. Okay. Sin A cos C. Sin A 1 by 2. 1 by 2. 1 by 2. 1 by 2. Plus cos A sin C. Root 3 by 2. Root 3 by 2. So it becomes 1 by 4 plus root 3 to root 3 becomes 3 by 4. It becomes 4 by 4. That is 1. The next one is sin A cos C minus cos A sin C. So 1 by 2 into 1 by 2 minus root 3 by 2 into root 3 by 2. It becomes 1 by 4 minus 3 by 4 minus 2 by 4 minus 1 by 2. Okay. See the 10th question. 10th question. In a right angle triangle PQR, Q, right angle at Q, PR, and PR plus QR is 25, PQ is equal to 5, PQ is equal to 5, this is given, and let us take this as X and this as Y. You are told that Y plus X, PR plus QR is 25. PR plus QR is 25. PR is Y, PQ is QR I taken X. Determine the values of sin P, cos P, tan P. Okay. So let us find out the unknown values first of all. So X plus Y is 25. You can take Y as 25 minus X. First of all, when we take Pythagoras, we know PR square is PQ square plus QR square. So PR square means Y square is equal to PQ is 5 square plus QR square is X square. But what is Y? 25 minus X whole square equal to 25 plus X square. Let us expand this. You get A minus B whole square. So 625 A square plus B square minus 2AB. A square. So this is 25 plus X square. X square gets cancelled. So 50X here, 600 here. x equal to 60 by 5, that is equal to 12. When x is 12, we know that y plus x is 25, y plus 12 is 25, y is 13. That means this is 12 and this is 13. Now what did they ask us to find out? Sin p, cos p, tan p. Sin p, opposite by hypotenuse to whom? Opposite to p. Okay, 12 by 13. Cos p, adjacent by hypotenuse. Adjacent to whom? Adjacent to p. So 5 by 13. Tan p. Tan p means opposite by adjacent. Opposite to whom? Opposite to p. So 12 by 5. Understand, guys? Okay. Now if you see the last question, 11th one, state whether the following are true or false. These are very important, which you may get as a 1 mark question in objective, and these are from the basics. The value of tan A is always less than 1. So suppose if I take a right angle triangle here, ABC, tan A is opposite by adjacent hypotenuse. Opposite by adjacent. Sometimes it can be 2 by 3, or sometimes it can be 3 by 2 also. So how it can be always less than 1? So first one is false. False. It can be more than 1 also. Secant A is equal to 12 by 5 for one angle of A. Okay. Secant A is 12 by 5. Let us check. 12 by 5 means hypotenuse by adjacent. It is right. Why? Because it is 2. How do you know, sir? It can be 5 by 12 also, no? No. It cannot be 5 by 12 because always the hypotenuse should be more than adjacent side. So it is true here. It is true. Third one. Cos A is the abbreviation of cosecant of angle A. It's wrong. Cos A means it is cosine, not cosecant. Cosecant is COSEC, right? So this is wrong. This is right. What did they say? Abbreviation of cosecant A. So third one is false. Third one is false. Fourth one, cot A is the product of cot and A. See, when we are writing cot A, it is not the product. It is the operator. Cot is the trigonometric operator, trigonometric ratio operator of an angle. So it is not the product. So it is also false. Last one, sin theta is equal to 4 by 3. Can it happen? Okay, sin 4 by 3. Sin theta means opposite side by hypotenuse. How hypotenuse will be less than opposite side? No, it cannot be. So it is false, because always the hypotenuse is the largest value in the right angle triangle, and hypotenuse can never be less than any of the sides of a right angle. So it is false. Understand, guys? Bye.